Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon to everyone. We have about 17 students now in the Google Meet. So I think I will start while waiting for some of our friends to join the session. Okay, this week we are going to, in this lesson, we are going to discuss about a new subtopic that is constant acceleration. Okay, but before I continue, I would like to remind again to all of you to join the Google Classroom. Okay, so if you have joined Google Classroom, you will see the class is listed in your Google Classroom lah, DMM 2523 Dynamics. Okay, dekat sini ada section M01. This is our section lah. Okay, when you click, you will find the announcement ataupun the posting that I have made. Tapi untuk dapatkan all the materials dengan lebih baik, you can click on the classwork. Okay, dekat sini I will list down the materials by week. So this is the first week of lecture. You will see it appears week 1 lah, and then the title of the topic that we are currently covering in week number 1, which is introduction and rectilinear kinematics. So ini apa yang kita discuss in week number 1, which is this week. So dalam ni akan ada beberapa link yang you boleh klik. For example, under course overview, you can view the slides. Okay, you can view the slides. This is the slides from previous lesson, previous class. Okay, as well as the lecture planning. And after today's class, I will upload the slides that I cover in this lesson today. And also under course overview, you can also see lecture video. So this is the video of our lecture on Monday. So you can click here and play back in YouTube. And you can also see that I have made some chapters here based on the topic that I am currently discussing. So it will be easier for you to find lah. So you tak payah nak scroll dekat mana-mana. You tak payah nak scroll randomly maksudnya. So you just go down here and see the topic will appear. So you can click on the topic that you would like to listen again lah, if you want to view the video again. And then di bawah ni saya kongsikan juga lecture slides. Okay, this is lecture slides for introduction. Okay, ini yang I have explained about the position, the velocity and so on. So this is the slides from Monday's class. So the slide from today's class I will upload here. And then in every class, I will be doing some tutorial together with you. So I hope that you have a piece of paper with you and also calculator and pen. So saya juga kongsikan macam mana pengiraan, the tutorial that we did in the class. So I share this with you also for your reference. So you have all the materials in this lah. Okay, so from today's class, when we finish the class, I will upload the slides in the lecture slides folder, and then I will also upload the tutorial in here. Okay, so please join the Google Classroom. If you know some of your friends who is in this section have not joined the Google Classroom, ask him or she to join the Google Classroom also. Okay, I hope everything is clear on the material punya delivery, how I will deliver the material in this class. Do you have any question on Google Classroom ke? Ada yang tak pandai guna ke? I hope everything is clear.
Okay, sir.
Okay, good. Okay, so let's continue with today's lesson. So today I am going to cover a subtopic that is called constant acceleration. Constant semua orang faham kan? Constant ni maksud dia tidak berubah. So acceleration tu ataupun pecutan, the object punya acceleration is constant. Dia tidak berubah. Okay, ataupun dalam bahasa Melayu kita panggil malar kalau tak silap saya. Okay, so the outcomes of today's lesson is first we will derive a few equations. This is not a new equation. You have already seen this equation in physics, maybe dekat sekolah menengah dulu, and also in basic physics in your first semester. So we will see again how these equations comes about. Maksudnya macam mana equation ni boleh datang. So it was basically derived from the basic kinematic equations yang saya tunjukkan pada minggu lepas. Okay, and then after we have got all the equations, basically there are three equations for constant acceleration. There are three equations that we can derive. So from these three equations, we will try to solve several problems. Okay, this is the tutorial part. So I will always combine theory in the beginning of the class, and then towards the end of the class, we will do a few tutorial. Okay. So I have introduced three important kinematic equations in the previous lesson. Anyone can tell me the important kinematic equations yang saya maksudkan ini? Siapa boleh ingat? Kinematic equation, siapa yang kita ada? Boleh seorang tolong jawab? What is the first kinematic equation yang melibatkan velocity? V is equal to apa?
ds over dt.
Correct. Thank you. Siapa dia ni? Ahmad Ferry. Okay, Ahmad Ferry. Betul. V is equal to ds over dt. Ini equation yang pertama kita ada. So ini penting. You kena hafal equation ni. Basically nanti sepanjang kursus dynamic ni akan ada banyak equation lain. Tapi sebenarnya semua equation ni datang daripada tiga equation kinematics yang saya tunjukkan pada hari Isnin yang lepas lah. Okay, so this is very important. The first one is V equals to ds dt. Okay, yang kedua, apa yang kita ada? Acceleration. A is equal to apa?
dv over dt.
Correct. Syed Faris, thank you. A equals to dv over dt. So ini equation yang kedua. Acceleration ialah perubahan velocity dibahagikan dengan perubahan masa. So kadar perubahan velocity itu yang dimaksudkan. Okay, seterusnya ialah what is the next equation? Kalau kita gabungkan ke semua ni, apa yang kita dapat? Apa yang kita dapat? Ada yang ingat? Kalau kita gabungkan kedua-dua ini, kita buat sedikit penyusunan semula, rearrange the equation of V and A. So what do we have?
A ds equals to V dv.
Correct. Thank you, Tarshini. So we have A ds equals to V dv. Okay. So now I will show you from these three equations how can we derive new equations for the case of constant acceleration. Okay, let me prepare my iPad to write this. Okay, now boleh nampak? Okay, sorry, tadi dia lost connection. Okay, so we have three equations now. V equals to V0 plus ACT. That is equation number 1. Number 2 is S equals to S0 plus V0T plus 1 over 2 ACT square. Dan yang terakhir is V square equals to V0 square plus 2 AC S times S0. Okay, so what we have here is basically from these three equations, we have derived another three equation for the case of constant acceleration. Okay. All right. So now let's try a tutorial if we can. By the way, today I have to finish the class a bit earlier. I'm planning to finish by maybe 2:45 or 2:50 because I have a meeting at 3. So please, we will try to do one tutorial at least, and maybe I will provide to you another tutorial in form of video. Okay, let's look at, do you have any question on the equations that we have derived? Ada apa-apa soalan?
Okay, sir.
Okay, okay, right. So kalau tak ada soalan, let's look at an example. Okay, mari kita baca soalan dia sama-sama dulu. A train starts from rest at station A and accelerate at 0.5 meter per second square for 60 seconds. Afterwards, it travels with a constant velocity for 15 minutes. Okay. Then it decelerates at 1 meter per second square until it is brought to rest at station B. Determine the distance between the station. Okay. So sekarang ni basically we have a train. Mari saya lukis lah. Saya lukis satu kotak sini. Kita assume that this is a train. Okay, so train ni travel from station A. This is station A to station B. Okay, ada berapa stage pergerakan dia ni? Daripada soalan ni you boleh tangkap ada berapa fasa pergerakan dia. How many stage? How many phase fasa? Ada siapa-siapa boleh jawab? 3, correct. Ahmad Daniel. Very good. So ada 3 fasa. So yang pertama is the train starts from A. Dia kata starts from rest. From rest at station A, accelerate. Okay, accelerate for 60 seconds. So dia dah bergerak sedikit, maybe sampai ke sini. Okay, this is phase number 1. Okay, so this is phase 1. So dia dah bergerak sampai ke sini. And then afterward, it travels with a constant velocity for 15 minutes. Okay, ni phase 1. Phase 1. And then it travels with a constant velocity for 15 minutes. Mungkin dia sampai ke sini. Okay. This will be phase number 2. Okay, so dia bergerak daripada yang pertama, daripada station A ke satu tempat dengan accelerate 0.5 meter per second square untuk 60 minit. And then dia masuk fasa kedua. Dia travel with constant velocity. Velocity dia constant. 15 minit dia berjalan dengan velocity yang constant. And then dia start brake, decelerate. Dia start mengurangkan dia punya pecutan dia. Pecutan dia berkurang. This is another phase. Okay, phase 3. Dia brake sehinggalah dia stop at station B. So this will be phase 3. Okay. Apa soalan dia tanya? Soalan dia tanya is, what is the distance from here to here? Dia nak tahu S. Berapa displacement? How long how far the train has travel? Itu soalan dia yang dia nak tahu. Okay. Let's start with phase 1. Okay, kita buat fasa by fasa. Okay, phase 1. Apa information yang kita tahu in phase 1? What is the velocity? Okay, remember in the kita punya equation ini, we need a few information lah. We need the velocity, we need initial velocity. Kita perlukan juga berapa acceleration yang constant dia, and then kita kena tahu masa dia berapa lama, and then kita nak tahu juga distance ataupun displacement. Ini yang kita nak calculate. Kita perlu tahu juga initial displacement dan seterusnya. Okay, basically inilah V, V0, AC, T, S and S0. So ada semua sekali 6 variable ataupun parameter yang kita perlu tahu untuk solve this. Okay, so phase 1, dia cakap start from rest. Apa information yang kita boleh dapat bila dia cakap start from rest? Start from rest maksud dia pada awalnya tak bergerak lah. Jadi velocity V0 ialah berapa? Initial velocity is, initial velocity is 0. Kosong, tak bergerak. Okay, and then apa lagi information next kita ada? Accelerate at 0.5 meter per second. Okay, so kita ada AC. is equal to 0.5 meter per second square. Ini acceleration dia. Next kita ada for 60 seconds. So kita ada time is equal to 60 seconds. Okay, ini je information yang dia bagi. Dan kita nak tahu apa? Kita nak tahu dia punya berapa jarak dia travel. Okay, so kalau kita patah balik ke equation kita tadi, kita nak S ni lah. Kita nak S ni. Kita nak tahu S. Tapi kita perlukan S0. Do you know what is S0?
0.
Correct. Walaupun dia tak bagi, tapi kita tahulah sebab dia baru nak mula berjalan. So basically, S0 is equals to 0. Okay, so ni information yang kita ada. S0 is equal to 0. So saya dah tulis dekat sini. Alright, so then kita akan guna equation tadi. S is equal to S0 plus V0 T, V0 times T plus 1 over 2 AC times T square. Okay. Then kita gantikan je lah value dia. S0 is 0, V0 is 0, T is 60 seconds plus 1 over 2, AC is 0.5 dan T square is 60 square. Okay, so daripada sini kita dapat S is equal to S yang pertama, S untuk fasa pertama. Dapat berapa? Cuba kira. 1 over 2. Sorry?
900.
900. Okay. 900. 900 unit is meter. Okay. So this is the first distance. So kita mungkin boleh tulis sikit dekat sini. Phase 1 from here to here, this is 900 meter. Alright. Now, let's move on to phase number 2. Okay, sekarang let me copy this. Okay, I will copy sekali dengan ni lah. Okay. And okay. Okay, now we have phase 1 is 900 meter. Kita sekarang perlukan phase 2 untuk tahu what is the equation, the distance for phase 2. Okay, bila kita go back to the equation here, we need for phase 2, we need to calculate S for phase 2, we need S0. Okay, S0 we have. V0. Okay, what is the V0 here? Untuk phase 2. Adakah masih kosong? V0 dia kosong ke apa? Anyone can give me an answer? What do you think?
900.
Okay, 900 tu dia punya displacement. Yang ni S0. Okay. Tadi pada fasa pertama, S0 dia 0 sebab dia belum bergerak lagi. Dia masih berada di tempat yang station A. Lepas tu dia dah bergerak. Okay, dan dia dah bergerak sampai 900. Lepas tu habis fasa pertama, mula fasa kedua. Fasa kedua mula tu, S0 dia bukan lagi 0. S0 dia dah displace sebanyak 900. So, S0 untuk phase kedua is 900 meter. Tadi pada fasa pertama, ya?
Kita kena cari dia punya V yang baru. Punya constant acceleration.
Betul. Correct. Tadi masa awal-awal, V0 dia kosong sebab dia mula daripada rest. Lepas tu dia dah memecut and then sampai ke fasa kedua. Bila fasa kedua, V0 dia bukan lagi 0. So, we need to find what is the value of V0 dulu. Okay. Saya tulis sikit. In phase 2, V0 is not equal to 0. Not equal to 0. Okay. V0 is not equal to 0. So, kita kena find what is the value for V naught. Okay, saya dah tulis kat sini. Okay, so kita go back to the equation dekat sini. To find V, this is what we need to calculate. V is equal to V naught plus ACT. Okay, so kita akan calculate the value for V pada fasa pertama sebab kita nak tahu apa V pada hujung fasa yang pertama. Okay, so saya akan kira di sini V is equal to V naught plus AC times T. Okay, V naught tadi kita tahu kosong, AC is 0.5, T is 60 seconds. So 0.5 times 60 kita akan dapat V untuk fasa pertama. Saya tulis sini V1 lah. V1 is 30 meter per second. Okay, so maksudnya apabila dia sampai pada hujung fasa pertama, dia nak masuk pada fasa kedua, V dia ialah kosong. Okay, so kalau kita tulis di sini, saya zoom in sikit. Okay, di sini pada permulaan V sama dengan 0. Dia sampai pada hujung fasa pertama, nak masuk fasa kedua, V is equal to 30 meter per second. Okay. Alright. Now we go back to here. So dekat sini kita tahu V naught is equal to 30 lah meter per second. Tadi kita dah calculate. Okay. Tadi kita nak calculate apa? Dia punya distance. So kita nak tahu what is the distance from here to here. From here to here. Berapa distance dia? Okay. So kita tulis balik the equation lah. S is equal to S naught plus V naught T, V naught times T plus 1 over 2 AC times T. Okay. Sekarang kita perlukan all the information yang kita nak. S naught. Siapa tahu value dia apa sekarang? Bukan lagi 0. S naught berapa? 900. Correct. This is 900 meter. V naught. Tadi kita dah explain. V naught ialah 30 meter per second. T. Do we have the value for T? Tengok balik soalan. Dia cakap, it travels with a constant velocity for 15 minutes. 15 minit. 15 minit ni berapa? T. T kita calculate dalam saat, dalam seconds. So, 15 minit ialah 15 darab dengan 60 saat lah. So, berapa kita dapat ni? 900 seconds. Okay. AC. Berapa value AC? Dia ada bagi tahu tak dalam soalan?
0.
Kenapa kosong?
Constant velocity.
Correct. Constant velocity. Dia ada cakap kat sini, constant velocity for 15 minutes bermakna AC is equal to 0. Velocity constant tak ada pecutan lah. Bila velocity berubah ikut masa barulah the train memecut. Dan T dekat sini again sama 900 seconds. Okay, then we have all the information. Sekarang kita akan gantikan. Okay, so S is equal to 900 plus 30 times 900 plus 0 lah. Half times 0 times 900. So this is 0. Okay, so berapa S? Fasa kedua. S2 lah saya tulis. S2. What is the value? 900.
900.
Berapa?
27,900.
27,900. So 27,900 meter. Unit kita punya calculation semua unit dalam SI. So unit dia meter. Bermaksud dia travel pada fasa kedua ni sejauh 27.9 kilometer lah. Tapi dalam kita punya calculation kita gunakan meter.
Nampak saya?
Okay. Sekarang screen iPad saya boleh nampak kan? Boleh nampak ke?
Boleh sir, boleh.
Boleh, okay. Okay, good. Okay, so sekarang kita tengah masuk ke fasa 3. So, macam saya bagi tahu tadi, fasa 3 ni dia berakhir dengan until the train is brought to rest. Maksudnya train tu berhenti di station B. So, pada station B, velocity is equal to 0. Velocity dia kosong lah, dia berhenti. Pada sebelum ataupun pada awal fasa 3 ataupun di akhir fasa 2 di sini velocity dia samalah dengan velocity di awal fasa 2 disebabkan dia bagi tahu velocity tu constant velocity, maknanya V sama dengan 30 tu kekal sehinggalah tamat fasa kedua. So mulanya fasa ketiga dengan V equals to 30. So kita tahu di sini V naught untuk fasa 3 is also equals to 30 meter per second. Okay, V naught sama dengan 30 meter per second. Okay, apa lagi information yang kita dah ada? S. Do we have information for S? S naught. Kita nak cari S. S naught. S naught kita apa? S naught kita apa? Ada yang boleh beritahu saya S naught, value S naught kita apa? S naught ni displacement yang train ni dah travel daripada awal tadi sampailah ke sekarang. Sampailah ke fasa 3. Berapa distance yang dia telah travel? How is the how long is the distance tu? Berapa?
27900.
2790. Okay, 27900 kalau saya zoom sikit dekat sini 27900 is for phase number 2, correct phase number 2, tapi the displacement is starting from station 1 tadi. So basically you have to plus with the displacement in phase 1 which is 900. So basically displacement is sorry. You don't have to plus sebab dalam phase 2 kita dah tambah. Betul So saya punya distance ni sebenarnya ada salah. This is not until here. This is actually until here sebab kita dah tambah dengan 900 pada sini. Kalau you tengok dekat sini we have add with 900 down here. Betul tak? Boleh nampak kan? Do you understand?
Yes sir.
Okay, good. So basically 27,900 is from the beginning. So correct yang you bagi tahu tadi, one of our friends. So this is 27,900 meter is from the beginning. So this is S naught for phase 3. Okay. Alright. So what is the information lagi yang kita perlukan? AC we have, V we have, V naught we have. If we look at the equation here, we have S, we have V naught, we have AC, we don't have the time. So we need to find the time first. Okay, we don't know what is the parameter yang kita tak tahu is time. What is the time and what is the S lah, yang ni yang kita nak tahu ni. What is the S? Okay. Alright. Okay. Sekejap saya minta break dalam 15 saat. Sekejap Ma. Siap. Dengarlah. Okay, sorry for the interruption. Okay, so sekarang ni we don't have the time and we don't have the S. That is the one that we want to find lah. So saya akan copy this and put in a new page. Sekejap Okay, I will paste it here. So this is the information that we have for phase 3. Alright. So daripada sini we need to find the T first. Okay. So daripada three equations that we have, we can use the first equation. V is equal to V naught. V kita ada, V naught kita ada, plus AC times T. AC pun kita ada. So, kita boleh dapat value of T from this equation. Okay, so bila kita gantikan, 0 is equal to 30, plus here jadi minus 1 times T. Okay, so we will have T is equal to 30 seconds. Okay, so maksud dia train ni break dalam masa 30 saat dia berhenti. Okay, that is the information that we have here lah. Okay, do you follow? Semua boleh follow Okay, good. Alright, so last part of the equation now is to calculate S lah. So we have S, the equation is S is equal to S naught plus V naught times T plus half ACT square. Okay, so S kita nak cari, S naught kita dah ada, so this will be 27,900 plus V naught kita 30, time kita dah kira di atas ni 30 plus 1 over 2, AC is minus 1 dan T is 30 square. Okay, so this will be our S lah. So, apa jawapan akhir kita untuk S? What do you get? 27,900 plus 30 kali 30, 900 lagi. And then, ini akan jadi minus lah. Minus 30 square bahagi 2. 30 square divided by 2, you get 450. So, 27,900 plus 900 minus 450. So, 28,350. Betul lah? Semua boleh dapat jawapan yang sama dengan saya? 28,350 meter. So, inilah merupakan distance di antara station A ke station B. So, this is the distance from station A to station B. Okay? Ada soalan? Any question on this topic?
Yes, sir.
Clear? Okay. So, again, as I said, I'm sorry that I have to end the class a little bit earlier today because I have a meeting. So, basically, in summary, today we have learned about the kinematics equation when the acceleration is constant. Okay, so kita ada 3 equation yang baru kita terbitkan, which is not baru lah. You have seen this equation pun in physics. Okay, so basically this equation mana dia datang? Dia datang daripada 3 basic kinematic equation yang penting ni. So that's why I think you have to memorize these 3 equation yang sebelah sini. Yang on the left hand side ni you have to memorize, and then you can derive these 3 equation yang for constant acceleration lah. Okay, so that is the first lesson that we learn today, how to derive the equation, dari mana equation for constant acceleration to datang, dan finally how to solve problems related to constant acceleration case. So I was planning to show you to solve 2 problems with you in the class today, but due to the time we only able to solve 1 problem. So never mind. I will do a video for you, a recorded video. I will record the video on how to solve the second problem, which I would like to show to you also. And then I will post in YouTube, and then you can refer later lah. You can refer later in the in Google Classroom. So that is what we have covered today. So before I end the class, do you have any question on what we have learned today? Anyone? Tak ada apa-apa soalan? Semua clear? Semua clear. So basically now we have covered rectilinear kinematics, continuous motion. So kita dah belajar tentang different parameters dalam kinematics, position, displacement, velocity, acceleration, dan kita dapat 3 equation penting. And then daripada 3 equation penting ini kita terbitkan 3 equation lagi dalam case di mana acceleration is constant. Okay. Cuma acceleration constant ni tidak semestinya constant pada setiap masa. So ada keadaan tertentu yang mana acceleration ni tidak constant. In that case you cannot use these 3 equation lah. Equation 3 ni hanya valid apabila acceleration constant sahaja. Okay. Okay, so sekali lagi I would like to thank you for attending the class. Before that, I would like to snap the attendance for today. You tak payah buat apa-apa, saya akan snap gambar je. Okay, this will be my record on your attendance lah. Okay, and then satu lagi before I end the class, I would like to know your feedback on the teaching method. Do you like this method ataupun you rasa saya kena perbaiki ataupun saya explain terlalu cepat ke? Ada apa-apa feedback on the method?
Okay je.
Okay, you boleh follow ataupun saya tak macam mana? Okay. Okay, so saya tak sure macam mana you nampak saya punya screen on your side dalam phone ke, dan macam mana you connect to Google Meet pun saya tak pasti. So I hope you can see what I'm showing clearly. Tapi kalau you tak dapat tengok dengan clear pun, you don't have to worry because I will always upload the lecture video dalam YouTube later lah, dan saya akan share di Google Classroom dan juga dalam WhatsApp group. Okay, so kalau tak ada apa-apa, thank you again for coming to the class. I will see you again next Monday, same time 2 to 4. Okay, next Monday kita akan masuk topik yang seterusnya lah, iaitu erratic motion. Okay. Okay, so kalau tak ada apa-apa, thank you class for coming. Assalamualaikum and have a good day.
Waalaikumsalam.